All right. We're going to wrap up section 8.2 right now. What we're looking at, as you remember from class earlier, was taking the derivatives of exponentials or logs that have a different base besides e. So far this year, we've done a lot of things with x as our base. All right, taking the derivative like we've done so many times, and then recently we've been working with what happens when our base is e. All right, e to the x, and remember the derivative of that is itself. So what happens then if we are finding the derivative of something that has a different base? All right, such as 2 to the x. All right, so going through the list of rules that you have in your blue sheets, the derivative of this is the natural log, whatever that base is, so in this case the natural log of 2 times the thing itself, 2 to the x. Okay, so this is rule number 5 on your list. The natural log of whatever the base is times the base and exponent. Okay. All right, now that only works if x is the exponent. Pretty simple. So what if it's anything but x? So now we're going to look at a chain rule problem. Natural log of 2 times 2 to the negative x, now times that by -1, which is the derivative of the exponent. So very similar to what we talked about earlier sections back in 8.1. If that is anything besides x, we're going to chain rule that and take the derivative of the exponent. Okay, that's rule number 6. Alright, so let's start combining some things together, old school, new school ideas. So now we've got, sorry about that. Now we've got x times 6 to the negative 2x. So this is product rule. So the derivative of the first part times the second part plus the derivative of the second part. So now we're going to use our new rules. Natural log of 6 times 6 to the negative 2x times the derivative of negative 2x, which is negative 2, all times the first part. And you can do some simplifying there. You can factor out 6 to the negative 2x out of each part, and when you're left over, you've got that times 1 minus 2x times the natural log of 6. Okay, so we're combining rule 6 there in that problem with the product rule. And of course, if we have the product rule, you know that you also have to be able to do the quotient rule. So anytime you want to stop this and try some of these problems on your own, all right, just push pause and work on things ahead of time. In this case, we got the derivative of the top part. So there's your natural log of 3 times 3 to the 2x times 2 times the bottom part, that x out in front, minus the derivative of the bottom part times the top all over the bottom squared. And of course you could probably do some simplifying there and rewriting, and we'll leave that up to you to do some other time as we just go through these different rules and example problems. Again, push pause anytime you want to try to attempt to do some of these problems. So in this next problem, alright, we're going to use that same thing we just did, but now we're going to try to find the slope of the tangent line. Should be relatively easy now. We already have the slope formula. Remember, the slope formula is the derivative of the function, and we're going to find that slope when x equals 1. So all we're really doing here is just taking 1 and plugging it in anywhere that we see x. And we've got a few places to plug it in. 2 times 1 is 2 for that exponent. Again, the same thing here, all over 1 squared, which is 1. And when you simplify all that, work that out, approximate, you get it right around 10.77. So what's that mean? That is the slope of the tangent line when x equals 1. So again, we can continue to do the old applications and things like that we learned throughout the calculus semester so far. All right, next one. Again, good opportunity for you to learn some new rules here. So now we're going to look at when we got log problems here. So we got y equals the common log of 2x. Remember, common log always implies that is log base 10. And so our rule for this, if you were following along on the blue sheet as well, rule number 8, we're going to go 1 over the natural log of 10, so the natural log of the base, times 2x, times the derivative of 2x. And when we simplify that, that is going to be 2 over natural log of 10 times 2x, and you can cancel out those 2's, and we've got 1 over x times the natural log of 10. Okay, that's rule number 8. Very similar. Alright, derivative of that, 1 over natural log of the base times what we're taking the log of times the derivative of what we're taking the log of. Next one. Now we're going to take the derivative of log base 3 of x times the square root of x minus 1 over 2. First thing we're going to do is we're going to apply some log rules to this problem. Remember, if you're multiplying things with logs, then you can add those things that have the same base. And if you are dividing, then you can subtract. So all I've done here is just taken this product and quotient and turned them into plus and minuses. I got one more step there of my log rules. You might recognize that I can take that square root and I can pull that out as a 1/2 power, pull that out in front, and rewrite it that way. Now at this point, I'm going to go through and take the derivative of each individual term. So in that first term, our rule is what? 1 over natural log of 3 times x times the derivative of x, which is just 1. In the next term, it's 1/2 times 1 over natural log of 3 times x minus 1 times the derivative of x minus 1, which is just 1, minus 1 over natural log of 3 times 2 times the derivative of 2. That's kind of important. Be careful there. That's a constant, so we know the derivative of any constant will always be 0. Doing a little simplifying here. And that right there is our final answer. Again, I guess you could have a common denominator if you wanted to, but this is certainly good enough for now. Alright, another one very similar to that. Why don't you try this one before I go through it. So once you see the problem, push pause, try to do it yourself, see if you can combine the use of log rules and the new derivative rules. Alright, hopefully you've tried it. Here's what I would do. First thing I would do is recognize I've got a quotient in this problem. And so this is the log of x squared minus 1 minus the log of x. Now I'm going to take derivative rules here. Take the derivative of each term. So that's 1 over the natural log of 10 times x squared minus 1 times the derivative of x squared minus 1, which is 2x, minus 1 over the natural log of 10 times x. And again, I could simplify that, put the 2x on top if I wanted to. Alright, but you get the idea from there. Alright, last example. Again, good opportunity for you to work on doing this without having me walk you through it. And again, try to do this first before you see the solution. Press pause after you see what I've written. Okay. Y equals x to the 3/2 power times the log base 2 of the square root of x plus 1. So the first thing I would do is I would rewrite it with log rules. X to the 3/2 power times 1/2 log base 2 of x plus 1. At this point, you're going to have to do product rule. So we're going to look at the derivative of the first part, which is going to be 3/2 x to the 1/2 power. Remember, multiply by the exponent, drop it by 1, times the second part. And again, there's a lot of simplifying you could be doing in this problem as you go. Plus the derivative of the second part. So we're using our new rules here, 1/2 times 1 over the natural log of 2 times x plus 1. And we're going to multiply that by the first part. And again, like I said, you could do a lot of simplifying here, but that is the general idea. Alright, so if you really want to simplify that, go for it. But I've done enough of that this year that I don't need to do it this instant. Alright, so there's some good examples for you. Use these examples, please, as you're working on your homework problems. I'm going to give you the homework assignment from the work that we did in class today, if you did not do it or didn't finish it, and then some additional problems from what we did tonight. But yes, look back at these problems, look back at your notes, look back at the video, watch those examples a number of times, go back and try the problems before you see me do it. Even though you've seen the problems already, go back and work on them again without having me walk you through it. Okay, so homework assignment from the problems in class, page 540, numbers 9 through 35 odd. And then from the work that we just went over, the examples and the rules that we just covered just now, that's page 540, numbers 37 through 55 odd. As always, you don't need to do everything, just do what you feel like you need to get practice to be ready for that upcoming homework quiz. Alright, if you have any questions, I'll talk to you tomorrow. Good luck.